Hi everybody, this is the third video in a series of transformation lessons that you have been watching or learning. All right, here we go. Grab everything you need. Of course, we're graphing, so stop the video when you need to and let's get going. Okay, so this is the parent graph for the day. It's an exponential. This is the first time we've done it this year. If you see my example here next to the equation to the x, I have this kind of curve shape, and that's because exponentials grow in multiples. So you multiply like 2 times something instead of adding. So I'm going to go ahead and make my table just like I always do. I'm going to use, in this example, or for exponentials, we use the basic x values that we've been using for lots of functions. And then I'm going to stick the x's in here really fast because I don't want to change color right this second. And then I'll come change my color for you so that it's really obvious what's going on. So this is 2 to the x, which is equal to y. So I'm just reminding you how this works. And what I'm going to do is just copy the base down. So we're copying the base down. And then, of course, your x values here are from the first part of the table. Now, calculating it's a little bit different because you're going to need some reminders how these work. So I like to block off 0 and the positive x's and the negatives. And I like to start with the positives first. They give us clues about what we need to do to find the values, and they're pretty fast to calculate. So right here, if you recall 2 to the 0, I'm going to just put that up there for you. 2 to the 0 is 1. It's not 0. So try to remember that. 2 to the 0 is 1. And these are rules of exponents in case you're thinking to the past as to what you're doing. And then 2 to the first, is just 2, so that's not that bad. And then 2 squared is 4. All right, so it's the ones on the other side, on the negative x's, that we have to be more diligent, or we have to think more about it. So for this one, I'm going to do it in red so it's easy for you to see. So what we're doing is we're going to get rid of this negative exponent. And the way we do that is we're going to take the reciprocal of it so that we can create a positive exponent. So I'm going to flip this around. And you can see here that my exponent became positive. So this is actually 0.5. And you can see it's still positive. The number is still positive 0.5. And then likewise here, I'm going to take the reciprocal because the exponent is negative. And so I'm going to flip the fraction around. And we get 1/4, which is 0.25. And you can see again the y value is positive. So then you'll come over to your graph and you're going to graph those things, and I'm going to stay color coded so you can see exactly where things are. At -2, we have 1/4, so it's really small, and that's okay. And then -1 is 1/2, so it's a little bit above it. And then, of course, the other points are a lot easier to graph. And then what is this? This is 1, 2, and then 2, 4. And then you can see that curve shape that I started out with. Now, there's something you have to be very aware of. So when I'm drawing this graph, what you need to notice, okay, so there's the beginning part. What you need to notice is if I continued the graph, so let's say I put in -3 here and I calculated 2 to the -3. What you're going to do is when you flip the fraction and simplify it, you'll get 1/8. And 1/8 is, it's obviously really smaller than 0.25. In fact, it's 0.0125. And so that would be down here. And so what's going to happen is as I go down the x's, as I go down the x values on the number line, what's going to happen is the numbers are getting smaller and smaller and smaller. The thing is, you're never going to have a y value that's 0, because remember, 2 to the 0 is 1. It's not 0. So what's happening is these points are getting smaller and smaller and smaller. They will never reach 0. So there is a bound there. So what's that bound called? It's called a asymptote. So this graph does in fact have an asymptote. So I'm going to draw that in now. So I'm drawing in, and let me go ahead and put it up just a little bit more. A little messy there. Okay, so it is y equals 0 is where the asymptote is. And so it is in fact part of the graph. The next one works exactly the same way. It's just base 3. That's the only difference. And I'm just going to cruise through that one pretty fast for you. Here I go. And I'm back. So we're going to do the factoring for the day, which is the perfect sum of cubes is what we're looking at. So how do I factor sum of cubes? Well, the first thing you're going to do is look for perfect cubes. So perfect cubes, and we practiced some of these before. Let's see here, cubes. And what does that mean? So 8 would be a perfect cube root. That would be 2, and just, another example, 27 would be 3. So something like that. So this is kind of a quick way to remember what the signs are in the formula, and I haven't talked about this before. So I like to use SOAP, and what does SOAP stand for? It's same. So what am I talking about? Same, here's the plus sign, here's same, and then the next one is opposite. And then the last two are always, always, and then plus. Okay, so that helps me remember what the signs are. So let's go back and look at it. So here's same and opposite, and then always plus. Okay, so if you can remember that, the formula will come a lot faster. So first thing I'm going to do in this problem, besides the signs, is I'm going to look for, do I have perfect cubes? So remember, that's the first thing you really want to do here. So I'm going to cube root, and I'm going to cube root, I'm going to ignore the sign. I'm just, not even look at the sign. It's not even part of what I'm currently doing. So when you calculate these, you're looking for, how can I undo the power? So that's kind of what you need to think about when you're doing this. So 2 to the third and x to the third, because 8 is 2 times 2 times 2. And then 27 is 3 power 3. And so when I cube root these, you can see that I can undo the power. So then, in fact, I do have perfect cubes. So when you do this, what I have, and I'm going to try to color code things for you, what I have is I have the a value, so that's the first part right here, is what's inside. So it's 2x. So we're looking at inside the radical. And then the back one I'm going to do in red. And that is just 3. So remember, it's the base. So then you go through and you just stick things into the formula, and that shouldn't be terrible for you. So let me go ahead and do that. So so I'm creating the structure. Remember, it's same because it's plus, opposite, and then always plus. So then I'm going to go through and put all of my A's in. If you like to work across, that is fine. But I think for people, some people need a graphic type organizer idea. So here's your A. And then you have to be careful about the next one, because here's your A, but you really have a parentheses around it, and you need to put the parentheses in. I actually want to see that on all your work, and I want to see that on any test or quiz. And then again, you have an A here. And then I'm going to go through and put all of the red B values. So this is, if you look at this, I kind of go backwards because that's where I'm just used to starting from, since this is in the back. So this is 3 squared. Okay, that's B squared. And then there's a B right here, which is 3. And then finally you have a B here, which is also 3. And then we're going to go ahead and clean up the expression. So this is work that I'm going to want to see from you. I'm going to want to see, hey, do you know if it's a perfect cube? Do you know how the signs are structured? Do you know how to find the A and B? Okay, so just going through it, and I am just cleaning stuff up. So this is 2 squared, which is 2x times 2x. So that's 4x squared, and then minus 6x, and then finally 3 squared is 9. Now you always want to ask yourself, can I keep factoring? I've mentioned in the last video, the answer is no. This last parentheses, when you're doing sum of cubes, will never factor. So 9 and 4 is 36, and you're never going to be able to find two values that fit that condition. Okay, so that's actually all I have for you today. My power's about to go off. I won't be able to check email until after 2 p.m. today, so it'll be between 2 and 3. Other than that, make sure you upload your notes to Google Classroom where the spot is. It'll say upload notes here. You don't need to do anything with Edpuzzle. If you feel like you want to resubmit though, the Edpuzzle so it registers your 100% after you watch it, that's cool too. Okay, I'll talk to you later. Have a great day.